When a standard large language model is flooded with complex, open-ended operational prompts, the architecture eventually stalls out. Traditional software as a service is a passive digital container. It remains inert until a human being sits at a keyboard to interpret the data and perform the labor. Labor as a service operates on a different logic, utilizing systems that execute tasks without manual orchestration. Achieving this level of autonomy hits a strict technical bottleneck, the context window. If a model is fed too many variables, its working memory overflows. When memory is lost, stateless models begin to hallucinate business logic, losing their grip on the operational reality they were meant to manage. True synthetic autonomy requires us to shed the passive API prompt cycle in favor of a rigid, self-governing operational infrastructure. Arch 3R functions as a structured back-end engine designed to translate probabilistic AI outputs into deterministic business logic. This engine requires a dual-engine memory architecture that strictly separates semantic concepts from hard data. It also necessitates a high-frequency, cyclical state machine that traps the model inside a controlled execution path. Isolating the model inside these two constraints eliminates administrative drift and prevents the logic from wandering into fabrication. This framework allows for the deployment of high-performance agentic nodes that function as reliable synthetic employees. To understand how this infrastructure replaces human labor, we must map the anatomy of the Arch 3 crossbow cortex from the ground up. The Toida loop serves as the rigid execution constraint that Arch 3 agents use to process every task. It begins with the trigger, where the system detects an environmental anomaly or a scheduled business event. In the observe stage, the engine ingests raw data via headless DOM scrapers or real-time WebRTC streams. This observation layer bypasses traditional user interfaces and human intervention, securing data directly from the environment. During the interpret stage, the model processes that raw data against predefined corporate schemas to find relevant signals. The engine then enters the decide stage, selecting a specific routing path or tool based on that interpretation. Finally, the act stage executes a deterministic action back into the business environment, closing the loop. This cycle operates at a high frequency, allowing the system to continuously monitor and correct its own outputs. The Toida loop strips the model of its open-ended freedom, forcing it to act strictly as a logic gate for back-end operations. High-concurrency swarm operations carry a risk of data corruption, particularly when multiple agents attempt to write to a single memory log simultaneously. The architectural solution is the crossbow cortex, which splits memory into two completely distinct silos. A quadrant node is responsible exclusively for unstructured semantic retrieval and conversational nuance. A parallel SQLite node maintains the hard mathematical state and business ledgers of the organization. A synaptic broker sits between these databases, utilizing Redis to synchronize them in real time. To prevent context window overflow, the synaptic broker uses fractal retrieval, querying only the precise fragments of data needed for the current beat. By pulling only these specific mathematical and semantic fragments, the system maintains a lean, efficient context. This decoupled memory architecture ensures the model only operates on verifiable facts, replacing hallucination with mathematical reality. In high-velocity autonomous deployments, the greatest danger is the blind spot, a logic failure that goes undetected until it's too late. This is why the system runs the Cassandra pre-mortem cognitive engine, a background daemon that operates independently of the main prompt cycle. Cassandra utilizes joint embedding predictive architecture to run reverse entropy simulations, assuming a plan has already failed and working backward to identify the cause. This allows the engine to causally map and identify operational gaps before they can execute in the real world. Resilience is further tested through the poison pill protocol within the staging environment. The system intentionally injects subtle mathematical errors into staging data to verify that the Aegis Sentinel veto triggers are sharp and reliable. This self-auditing architecture ensures the AI swarm is proven to fail safely in a sandbox before it ever touches a live production workflow. The completed crossbow cortex is an engine that ingests reality, cross-references it against dual-state memory, and executes simulated safe logic. Attached to this core are the arrows, discrete execution containers that form a customized modular swarm. These independent arrows access the shared memory infrastructure through local Model Context Protocol ports. The digital I/O layer uses headless browsers to achieve complete dominance over web-based tasks. For physical operations, the Meta HUD integration intercepts live audio and visual feeds with zero latency. By combining this physical world interception with headless digital execution, the system creates a truly unified, omnipresent synthetic workforce operating without human friction. A system with this level of access requires absolute data sovereignty to be viable in an enterprise environment. Arch3r's isolated passport system allows this architecture to run air-gapped using local models like Ollama or VLLM. Because the engine runs locally, your proprietary operational models are never exposed to public training pools. Concluding tone, labor as a service represents the deployment of an owned, sovereign intelligence engine, one that permanently eliminates operational drift.